And hello and a really big warm welcome to this presentation from the Urban Penguin. My name is Andrew Mallett, and today we're going to take a look at the difference between interpreted code and compiled code. We're going to be taking a look at how long it takes to say hello world in Python, and then we're going to look at how long it takes when we look at running a similar program in a compiled language such as C. Come on, let's find our command line. So hello and a really big warm welcome through to the command line of my Ubuntu system, an Ubuntu system where we can investigate the differences between compiled and interpreted code. Python is an interpreted code, and we can begin by taking a look at our hello.py file, our Python script. When we look at it, it's relatively simple with the print function and the text, the message that we want to print, hello world. So we might think this simplicity is going to give us some advantages in execution. The downside is that an interpreted language, the interpreter, Python 3, has to then read the code line by line and interpret it and compile it into machine code on a line-by-line basis. Now, this is fine. It's going to appear to run relatively quickly. However, the compilation has to happen each and every time the code is executed. When we look at this, when I run with Python 3, so the interpreter, telling it to interpret the hello.py file, of course, then I get the hello world statement coming out. And that's, of course, what we would expect. And it didn't take long. I'm certainly not suggesting that we needed to wait for that. But let's interrogate how long it took to run. I can repeat the last command and arguments with a double exclamation mark, and we can see that it really didn't take that long to run, 0.012 seconds. So certainly not a long time at all. But built into that is the time it took to compile. We can see now running it again, it took 0.013. Running again, we can see it's 0.019, almost getting up to 0.2 seconds. So I'm not suggesting this is a long time, and the advantage that we have with Python is that our scripts are always going to be cross-platform because they are pure text files. But we have the overhead of having to run the compilation every time we execute the code. Whereas when we take a look at our C source file, hello.c, it might look a little bit more complex. And that's the nature of the language of C. The include statement is for the compiler to include an additional library for standard input and output. We have a main function, and inside of that main function, we're printing hello world and a new line, and we're returning success once it has executed. So the lexics of the language is a little bit more complex. We also can't just execute our source file. We need to first compile the source file. And we can do that with the GNU C compiler, GCC. We can specify the output, the executable we want to create, as hello. And we can read in then our hello.c, our C source file. Now, again, it really doesn't take a long time to compile. But the big thing here is that we only need to compile it once. We have now created a binary file that is suitable for this operating system and this architecture. So every time that we execute it, we don't need to worry about the compilation. When I use the file command to look at the binary file hello, we can see a little bit of information saying it's compiled for the architecture x86-64, and we can see how it's being compiled, but it's being compiled for Linux on the x86 64-bit architecture. So if I tried to take this across to a Windows machine, it's not going to run. But when I execute it, we can see then that it executes and prints the hello world. When we try timing it, we can see that it took 0.002, so substantially quicker than we saw before with our Python script. We can try it again, and it's extended a little bit to 0.006. Let's try it one more time when we execute this, and it's gone back to 0.005. Shall we give it another go? And look at this, we've got back to 0.02. So all of our executions are substantially quicker than the 0.015 that we had seen with the execution of our Python script. Our Python script always then has to be compiled at execution, whereas when we look at a compiled language, the advantage is that it only needs to be compiled once, but it does need to be compiled for each architecture and operating system it's destined for.
All that is left to say is thank you for watching. If you've enjoyed this, then you are probably sadder than I first thought. For more of this drivel, please subscribe, like and comment to @TheUrbanPenguin.